Assalamu alaikum everyone. Welcome to our lab number 4. Lab number 4 is about stacks. So as usual, we are going to learn how to implement a stack and also how to use a stack. If you have downloaded lab 4 from the Blackboard, you will see these two items as usual, the document and the NetBeans project. So I have already opened both. I have opened the lab document. I have also opened the NetBeans project from within NetBeans. Okay, so if you see the project contains many files. These are all examples that we have already seen in the lecture. So I don't have to explain them in detail again, but at least we're going to run them to see how they work. See, the reverse string example is here, delimiter matching is here, and then add large integers is here. But before that, we have to look at the implementation of stack once again using linked list, and then also test it as we did with singly linked list and doubly linked list. We tested them to see how they work. So again, here you have test IntegerLL stack. Let's go through the document because the document will explain all of this. Okay, so in form of examples, the document says the class test IntegerLL stack shows how to use the LL stack, which we implemented in the lecture. It performs the following operations. So it will allow the user to push an element in the stack, to pop an element, to get the top element. So these are the three principal methods of stacks, testing them, and then there is a test for print all, clear stack, and then quit. Okay, so we're going to run this example, but just before that, let me remind you how we implemented the stack itself, the LL stack. Okay, LL stack was implemented based on Java's linked list. So we had to import the linked list from java.util and create an object of linked list. So we will be implementing method of stack using method of this Java's linked list. It's important to take note of this because, like I said, you will be asked as part of this lab to write your own stack, to implement your own stack using the DLL class. And therefore, we're going to call that stack DLL stack instead of LL stack. Okay. So the method of linked list, the most important ones are push. Okay. So to push an element, just call the add method of the list. Then there is pop. Again, to pop, you just call remove last. Okay, but make sure to check that the stack is the list is not empty. If it is empty, you throw an exception. Similarly, top element, we implemented it by calling the get last method. So these are the important methods. The rest are easy. Clear the stack means clear the list, and to check whether the stack is empty, you check whether the list is empty. This is very easy. This is how we implemented our LLL stack. The next question is, does this stack works? Is it good? Are the functions working as expected? Okay, so for that, the document says you are given a class called test IntegerLL stack. So this is the one I need to explain and then run it so that you see how it works. This is the test IntegerLL stack. Okay, it's very similar to test DLL or test singly linked list. Test integer, DLL, and test integer SSL as we saw before. So the first thing we do is we create an object of LL stack. In this case, LL stack of integer. Okay, equal to new LL stack of integer. So we're going to be pushing element, popping element, and so on using this stack. There is a variable option which will allow the user to choose one of the options as before, and also there's a scanner object which will allow the user to enter some input. Okay, so we do it as usual using a do while loop, display the menu, receive an option, then handle that option. So that's how it goes almost always. Okay, so these are the menus as we mentioned: push an element, pop element, top, get the top, print the stack, clear the stack, and quit. So we allow the user to select his option, and we read it using next int, save it in the variable option. And the next step is to use a switch statement to handle the appropriate case depending on the value of option. So if option is 1, it means the user wanted to push an element. So we have to ask the user to provide the element to push. So we say enter the element to push. We read the element and we push it to the stack by calling the stack.push. So basically we are testing the push method. All right. What if the option is 2? It means he wishes to pop out. So here it's important to check that the stack is not empty, because if it is empty, you cannot pop out anything. So that's what we are testing here. If not is empty, then we're gonna pop and print. Now notice that pop is not a void method, so you have to call it as part of print line statement, because we want to print the result returned by the pop. So we say system.out.println top element, so this is the value, has been removed. Okay, but if the stack is empty, we just print a nice error message here: sorry, the stack is empty. Okay, now similarly for the top element, it's gonna give you a value, so you have to call this method inside print statement. You see, for push, because it is void, you don't need a print statement. Okay, you can call it on its own. Just stack.push, read the value, and pass it to the push method. But for methods that are not void, normally you have to call them within the print line, because they will give you a value, and we want to usually print that value. Okay, so print the value returned by pop. Here, print the value returned by top element. Okay, now stack has a toString, therefore you can print it. You can just say print line the stack. This will automatically call the toString method to get the elements in the stack and print them out. And the final option is to clear the stack. Let's run this example to see whether our stack will work correctly. So as usual, you right click and you say run file. Okay, so this is the program running. It displays the menu. So suppose we say option 1 to push the element to push, let's say 5. Okay, if you print the stack at the moment, it will have only 5. So option 4 to print the stack, you can see that it has 5. All right, let's push one more. If we push 10 and then print option 4, you see the stack has 5 and 10. So the assumption is this is the top of the stack, so 10 is at the top. Let's push one more, push 15 and then print option 4, and you can see 15 is now the top of stack. Now the question is, if you pop, what do you think will be removed? Obviously, since this is a stack, the top element is going to be removed. So let's try that. So option 2 to pop, you see that it says element 15 has been removed. Okay, because 15 is the one at the top of the stack. To confirm that, let's print the stack once more. Option 4, and you see the stack now has only 5 and 10. Okay, that's the idea. One more time, let's pop the top element. It's going to remove the 10. You can see it said the top element 10 has been removed, and if you print, indeed there will be only one element, which is 5. So this is the idea. One more time, let us push an element. Let's say 20. 20 will be at the top of the stack. If you print, you will see it, behind 5. So it means our pop and push methods are working exactly as expected. The last option is clear. If you say 5 to clear the stack, okay, and if you print now, you should see that the stack is empty. Okay, so that's the idea of this simple class that is designed to test the methods of LL stack. Good. Now, but what we really want is to see how to use the stack in solving problems. We want to see how it is used in applications. So for that, we are given 3 examples as already discussed in the class. There is a reverse string, add large integers, and test delimiter matching. So all these examples, we're going to now try and run them to see whether they work as explained before. Starting with reverse string. So reverse string, if you recall, is a method that will take a string from the user. It creates a stack of character. Then it will push all the characters in the string S into the stack. Okay, so we just need a loop from 0 until the length of the string, get the character at I by calling the char@, method, and push it onto the stack. Then pop out all the characters. If you wish, you can use a while loop here. Actually, you can say while stack is not empty, pop and append your string variable here. But there is no need. We know that we have put all the characters in the string S in the stack. So we can use a loop that goes as long as the number of characters in the string. Okay. So you see, before the loop, we define the string variable initially empty. So basically, each time we pop, we will append to that string variable, which is called result. So at the end of the loop, the result will have all the characters that we pop out. You just need to return this string. Notice that the reverse string doesn't do the printing, it only returns the result. We will do the printing in the main method. Okay, so it receives a string and return another string, which is the reverse of the one that is received as input. Okay, good. So this is the method. Now let us see how we use it from the main method. So the main method, first it creates a scanner object, and then it asks the user enter the string to reverse. Now to read the string, we need to use next line. So you say reader.nextLine. Save it in a variable S, and now we want to call the reverse string. Now reverse string is not a void method. So as usual, you will need a print line method to print out the result that it is going to give you. If a method is going to give you a value, you should call it as part of print line. I keep emphasizing this because many students still don't understand the difference between calling a void method and a non-void method. A void method, you call it alone. You don't need a print line statement. But if a method is not void, you have to call it as part of print line to print the result it will give you. Or you can call it as part of an assignment statement to save the result it will give you in a variable. This is another option. But in this case, we want to actually see the output, so you call the print line method. So you say print line, the string reverse is, you call the method reverse the S that we just read from the user. Let us run this example. So run file. So let's use the same example I was showing you in the lecture. Suppose the user says salam. Okay. And you can see the output. It says the string reverse is malas. Okay. What if you say the string is salam shabab? This is the output you get. It's a babash malas. So you can see the string is printed exactly in reverse order. B first, then A, okay, then B, then A, and then this one, then the space, and then MALAS, like that. So the string is completely reversed, and this is basically the idea of a stack. Good. So this is our second example. Next example is let's try the delimiter matching one. Okay, for the delimiter matching, I would like us to try some of the expression that we were given in the slides. So let us try, for example, this one, or let's try the middle one here as an example of expression that is valid. Okay, so if you read that and then you run the program, run file. So it says enter the string to check for matching brackets. So this is my string. Okay, press enter and it is telling you the brackets are matching. Okay, let us try one of the invalid ones, like this last one here. Okay, if you run it, let's run the program one more time. Run file. See, it says the brackets are not matching. Okay, so the program is working correctly. Let us remind you quickly what the program is doing. We have this method called delimiter matching, which is Boolean. So it's going to receive a string S, and it's going to try and check whether the brackets, which could be any of these three types of brackets, whether they are matching. So how to do that? First, create a stack of characters. This is the main thing. We are using stack to solve this problem. So it is showing you an application of stack. Okay, so we create a stack and then we go in a loop going through each character of your string S. Say for int I from 0, as long as I is less than the length of string S, get the character at I using the char method. So we're gonna get the character at I, save it in CH. And as we remember, there are just two cases that we need to worry about, whether the character is any of the opening brackets. So here it says if CH is this or this or this. If it is any of the opening brackets, just push CH in the stack. So stack.push CH. Else if, notice here you have to say else if. You cannot just say else, because if you say else, it will mean anything other than left brackets. No, we want to ignore the other characters. We are only concerned with the closing brackets. For other characters, ignore them. So we need an if statement to check if the character is this right bracket or this right bracket or this one. If it is any of these, then there are two issues. One, the stack shall not be empty. So we need an if statement to check that. If stack dot is empty and you have a right bracket, definitely something is wrong, so return false. Okay, else there is one more condition to check. this right bracket, does it match the one that you're going to pop from the top of the stack? Okay, so again, we need a method called matching bracket, and we are saying if not matching brackets, the top element from the stack, which is going to be a left bracket, and ch, which is one of the right brackets, if they do not match, again return false. If they match, we cannot return true at the moment. Remember, we can only return true after we finish checking the whole string. Okay, yeah. So, but we can return false immediately if there is a mismatch. Now, this method I showed you in the lecture, it is a very small method that will receive 2 characters and will return true if one of these 3 conditions is true. Okay, if character 1 is this left and character 2 is this right, return true. Or if character 1 is this left and character 2 is this right, again return true. Or the same thing with the other type of bracket. So it will return true if the 2 brackets are really matching left and right. Otherwise, it will return false. So that's how we use it here. It's a Boolean method. So you just call it as part of if statement. So now at the end of going through all the characters, we now need to check, because the stack should be empty after you finish all the characters. So we check if the stack is empty, return true, the brackets are matching. Otherwise, return false. Alright, so this is the method. How do you test it? You do that in the main method. So as we saw with the other example, the reverse string, we need to create a scanner object and then ask the user to enter his string. Read the string as S. Okay, using read line. Now, since our method delimiter matching is Boolean, we shall call it as part of if statement. So if delimiter matching S, we print the brackets are matching. Else, the brackets are not matching. Okay, so this is the program I just ran, and you saw that it works for the expressions that are really valid, and it also shows us false for the expression that are not valid. Okay, so this is our example number 2 or 3, depending on whether you consider the testing of the stack itself as an example. Okay, the last example is adding large integers. Okay, adding large integers. We also explained this in detail in the lecture. So we'll just look at it briefly again here. So the idea is you have numbers, but they are too big to be represented as integer values. So they are represented as a string. Okay, and the method here add is trying to add them. Even though they are string, can we still add them? Okay, we saw the algorithm. You need 3 stacks: stack 1, stack 2, stack 3, stack of integers. Okay, go through the digits of the first string and push them in stack number 1. But remember to convert each character to an integer. And you do that by saying character.get numeric value. Okay, so you get the character at I, convert it to number n, and then push the n in stack number 1. Go and get the next character, convert it to number, and push it. So by the end of this loop, we will have pushed the digits of the first number in stack number 1. Do the same thing for the digits of the second number. Okay, push them in stack number 2. And then this is our loop. We have variable results, ns1 and ns2, and then the loop will repeat as long as at least one of the stack is not empty. Okay, so if stack number 1 is not empty, pop from it, save the value as ns1. Do the same thing for stack number 2, save the value as ns2. And now add ns1 plus ns2 plus result. Okay, get one number and save it in result. Now this number, you have to split it into 2. The unit part should be pushed in stack number 3. To get the unit part, you have to use the remainder operator. So you say stack3.push result remainder 10. This will give you the unit part. Okay, then get the tens part by saying result slash 10. This one, save it back in result. We're going to use it for the next operation now. Okay. Okay, before you start the next operation, reset ns1 and ns2 back to 0 and repeat. So this will continue until both the stacks are not empty. Final thing, before you start bringing out your result, you have to check if result is not 0, you have to push it in the stack. Okay, and then now to get your result, just you need to pop out from stack number 3 and append to a string variable answer. So here we say while stack 3 is not empty, pop from stack 3 and append to answer. So once you finish the loop, just return answer as your result. So this is the method. Again, to test it, you need to call it from the main method. So we need to ask the user to enter 2 different numbers. So we need a scanner object. Enter the first integer, and we're going to read it using next, because the assumption is it's a string. So you cannot say next int, because integer cannot hold this number. The assumption is it is too big to be saved in an integer variable. So save it as a string s1. Read the second number, save it in string s2. Now we are ready to call our method. Again, notice the method is not void, so you cannot call it alone. You have to call it either as part of print statement or assignment statement. Since we are interested in printing out the result, the right statement to use is print line. So we say print line, the sum of the 2 integers is add s1, s2. This is how to call the method. Add s1, s2. So s1 will go to n1 here, s2 will go to n2 here. The method will do the processing and return to us a single string. This is what we are printing out. This is how this method works. Now let us run it like we did with the other examples. If we say run, and this time I'm going to enter a really very big number which you cannot hold as an integer. Let us say we have 555555555. Okay, a number as big as this definitely cannot be saved in an integer variable. Okay, integer variable, the maximum range I think is about 1 billion or something. Okay, enter the second number. Let us say 2. Let's reduce it. Let us make sure it is about the same length. Okay. Now let us see the output. So suppose we want to add these 2 integers. So they are going to be read not as numbers but as strings. The question is, what is the sum of these 2 strings? This is the answer. Say the sum of the 2 integers is, as we expect, 77777777. Okay. Yeah. So no matter how long your string is, provided it contains digits, okay, it can be added using our method. This is the idea. So these are the examples for this lab. Now what are the tasks? All right, so you have about 3 tasks to do. Let's start with the first one, which is very easy. He said you are given the dll.java file. The same like we saw in previous labs. It implements a generic doubly linked list as we saw in lab 3, but it has been updated to include additional methods that you need for stack and queue. Essentially, if you recall in the task that you are asked to do for the doubly linked list lab, one of the tasks is to add a method getLast, and another method is to do toString. Now, because we need them to implement stack, I have added this method for you. Okay, if you go and check the DLL class, same like before, it has everything that you expect, plus now in addition to getFirst, we also have getLast. Okay, getLast was left to you to do as a lab task, so now I have added it to the class. So to getLast, basically you just have to return tel.info. But before you do that, you have to make sure the list is not empty. So you say if tel is not null, return tel.info, otherwise return null. The other method that you are asked to do as an exercise is toString method. So we want to represent all the elements in our linked list as a string. So we define a string variable here. Okay, here I initialize it with an opening bracket. You could have just returned the string without the bracket. So in that case, this should be empty string, but it doesn't matter. So initialize s to an opening bracket. Then initialize, we use a loop as usual. We are using for loop, initializing temp to head. Okay, and we're going to traverse the whole list. Therefore, we're going to keep repeating as long as temp is not null. Okay, what do we do each time? We append temp.info to our s. So s plus equal to temp.info. But also remember to add an empty space so that the elements will not merge together as one number. We want them to be separated by space. So we're going to add temp.info plus space to the current s. Go and update temp to temp.next and repeat the process as long as temp is not null. Okay, so by the time this loop finishes, okay, so our string will contain all the elements with a left bracket at the left side. So now just add a right bracket at the end and return the s. Okay, so this is how to implement the toString method. So this you are asked to do as a task, but now because we need this class to implement the stack, I have given you these methods. All right, good. So what are you supposed to do? It says use this class to implement a class called DLL stack that represents a stack for processing any type of value. So it has to be generic. Okay, actually all you have to do, Shabab, is go to LL stack, just refactor it. So copy it, paste, and refactor it, and rename it as DLL stack. Okay, then we don't want to use the Java's linked list to implement the stack. We want to use the DLL. So you have to change this to DLL of type T, list equal to new DLL. So we're going to use our own doubly linked list to implement a stack, not Java's linked list. So if you like, you can delete this import. We are not importing anything from the Java library. Okay. So after creating a DLL object, now use it to implement the method of stack. So basically all it means is instead of calling methods of linked list, we will be calling method of DLL, the corresponding methods. Yani. For example, in push, definitely we don't have add method in DLL. So you have to ask yourself, which method should you call in DLL to achieve push? Okay. Similarly, we don't have remove last. So which method of DLL will you call that will do the same job as remove last? This is the idea. But the method we are implementing are the same. They are method of stack. A method of stack are push, pop, top element is empty and clear. You need to implement these methods, but not with the help of method of linked list, with the help of method of DLL. I hope this task is very clear. So once you are able to create your own stack, the next step in B here is to test it. And we're going to test it with double values. Okay, so you don't need to start from the scratch. We already have a class here called test IntegerLL stack, which is testing LL stack, but with integer values. So you copy it and refactor it as test double stack, and you need to modify it in two ways. Number one, we don't want to use LL stack. Let me show you the class. This is a class you need to refactor. Okay, and the first thing is this should not be LL stack, because we want to test the stack that you just developed, which is called DLL stack. So you have to create an object of DLL stack. This is difference number one. Difference number two is it should not be of integer. It should be of double. This is what the question is saying. Okay, to manage double values. So now go through the class to make the necessary changes. Okay, for example here, option of course is still integer, but when you want to add a new element, you don't say next int, because you're not adding integer values, you're adding double values. So this has to change to next double, and so on. Go through this class and see what changes do you need to make so that the test class will manage double values. Okay, this is basically what this task is about. The second or the third part is again testing your DLL stack, but this time with students, with student objects. So it says save test double stack, which you have done from B, as test student stack, and update it to manage student objects. So again, this is very clear. Once you create a DLL object, it has to be now DLL of student, not of integer. DLL stack of student. So obviously, if it is student, to add an element, you cannot just say stack.push. You have to read the input you need to create a student object. So you need an ID number, the name, and GPA. So you have to say enter ID, you read ID, enter name, you read name, enter GPA, you read GPA. Then you will say stack.push new student ID name GPA, exactly like we did in previous labs. Okay, so try that managing student object with your stack and see whether your DLL stack can also manage student objects. So this is what this task 1 is about. Okay, if you are able to do that, then definitely your DLL stack is good. It is able to manage any type of data. The next 2 tasks are going to see if you can use it in other applications. Okay, not just testing to see if it works, but can you apply it to solve a problem. So we have 2 different tasks. The first one is very easy. Let's go through it. It says a simple algorithm to check if a string is palindrome. Now, what is a palindrome? A palindrome is a string that reads the same way, whether you read it from left to right or from right to left. A good example is Madam here. Madam is a palindrome. If you read it as in English from left to right, it's Madam. Also, if you read it in Arabic way from right to left, it is also Madam. So this type of string is called palindrome. Now we want you to write a program that can check whether a string is a palindrome. You need to write a method, yani. So the method will receive a string, and it's a Boolean method. It's going to return true or false. You can see the signature of the method here. Okay. Public static Boolean is palindrome string s. It's just supposed to return true or false. Now, how does it do it? Here I have given you the algorithm, how to do it. It involves two steps. First step, scan through the string and store each character in a stack. Okay, so read through the string and push each character in the stack. So you're going to push M, you push A, you push D, you push A, you push M. All right. Then do another scan within another loop. So scan through the string the second time, comparing each character you pop with each character in the string, yani, with the character you're going to pop from the stack. Okay. If there is a mismatch at any point, return false immediately, because the string is not going to be a palindrome. But if there is no mismatch, after the loop, return true, that the string is palindrome. So the idea is you push the characters in Madam in a stack. Okay, let us say this is our stack. It's going to contain Madam. Let us assume it is all small letters. Okay, so Madam. This is our stack. So this second loop, the first loop, of course, this is what it will do. Just push these characters in the stack. Okay, let's assume this is small m, not capital M. So push the characters. So if you push them, of course, M will go first, then A, then D, then A, then M. So this is the first step. The second step, you're going to go through your string one more time. But this time, you will compare the character that you just get using character at I with the character that you're going to pop from the stack. Okay, obviously M will match the M here at the top of stack. Okay, then next character, match it with the character at the top of stack, which is A. So again, they are matching. The next character, match it with the next one you're going to pop. You see, they keep matching. This A will match this A, and this M will match this A. So all the characters are matching, therefore after the loop, return true. Okay? But suppose what you have is not Madam. Let's say it's Salam. Okay? So you push Salam in the stack. Okay? Now go through the stack. Go through the characters again. The first character is S. Does it match the top of the stack? Obviously no. So return false immediately. This is not a palindrome. This is the idea. Okay. So you need to write this method. And actually, I will give you a hint. This method is very similar to reverse string. Very similar to it. So if you wish, you can actually refactor reverse string and rename it as test palindrome. Test palindrome. Okay. So of course this should be matching the signature of the method that I have just shown you. The signature is public static boolean is palindrome. All right. Now you need to create a stack of characters, so no change here. You need, for the first loop, push all the characters in the stack, so no change here. Okay. The change is here. Okay. We will need another loop, and the loop is, as I just explained, you will get the character at I and compare it with stack.pop. Okay, if the two characters are equal, if they are not equal, return false. Do you have to say else return true? No, you cannot return true now. We can only return true at the end of the loop. Okay, so that's the idea. You need a loop, but in the loop you will have an if statement that will be comparing the character at I against the one with stack at pop. If they are not equal, return false. No else, no else. You don't have to have else part. Okay, after the loop, return true. Okay, so this is all you have to do. Modify this method to achieve the palindrome. Then in the main method, you're going to read a string from the user, and then since the method you have is a boolean, you need an if statement to say if is palindrome s, print the string is palindrome, else sorry, the string is not palindrome. So it's not a simple print line you need as before, because your method is returning boolean. Okay, if it is boolean, normally you call it as part of an if statement. If is palindrome s, print line the string s is palindrome, else sorry, the string s is not palindrome, something like that. So this is what this task 2 is about. You just need to refactor reverse string and update it to do what you are supposed to do here. The last task is very interesting. If you recall, I have shown you 2 algorithms in the lecture that deals with postfix expressions. One algorithm will do the conversion and another algorithm will do the evaluation. Now the algorithm for evaluation is much simpler, so this is the one I'm asking you to do here, to implement as a code. Okay, basically this is the algorithm. If you recall, you need to create a stack, okay, and then you need to read from the user the string. Well, since we are receiving it as a parameter in the method, we just assume it has been passed to us as parameter. The reading you will do in the main method. Okay, but this is the critical part. You're going to go through the string in a loop. So you're going to check if your character is an operand. If your character is an operand, convert it to int. This is very important because you are character at I is going to give you a character, even though we know what you receive is a number. So you have to convert that character to a number. How do you do that? We already saw how to do that. You can use the get numeric value method. I think we saw that in the in this add large integers. If you give character to this method, character.get numeric value, it will give you a number, an integer number. So that's what you have to do. Get the number and push it in the stack. So if you see an operand, just push it in the stack. Else, if the character is an operator, okay, so is there a method that can tell you whether a character is an operator? Unfortunately, no. But you can write a small method to do it. Okay, we know the operators. You can just say if character is equal to times, or character is equal to slash, or character is equal to this, return true. Okay, otherwise it will return false. So you can have a small method to check if it is operator. So if it is operator, what do you do? According to the algorithm, you have to pop 2 numbers from the stack. And remember, the first one you pop should go to the right. So if you call it operand 1 should go to the right. Pop another character, call it operand 2. Now apply your operator. So it's going to be operand 2, operator, operand. If it is a minus, operand 2 minus operand 1. Get the result, save it in the variable result, and push this result back in the stack. This is the algorithm as we have already explained. At the end of this loop, there will be only one number in the stack, that is your result. So return it as your final answer. Okay, so this is what you are going to implement in this task number 3, and these are the possible operators. Okay, it could be times, it could be slash, it could be remainder, or it could be plus, or it could be minus. Okay, so it says use your DLL stack to write a Java program called test postfix. So here there is no really a good example that you can just refactor. The closest one probably is this add large integers, but they are not very similar actually. Perhaps the only common thing is you need this method. Okay, so if you wish, you can start from scratch or take any of the example and refactor it. But basically we need a small class with a method that we saw there. The method name is evaluate. Okay, so evaluate will take a postfix string and return an int value as the result. Okay, and then you will have a main method which will ask the user to enter his expression. The expression has to be a postfix, and it will tell the user that the result of evaluating your postfix is this value. I have given you some sample output here. If the user provide any of this expression, which are also there in the lecture, this is the result. Okay, if the user enters this as his postfix, this is the result, and so on. So the idea is to test the second algorithm about postfix, which is the one doing the evaluation. This is the easier one actually, because there are only two cases. Either a character is an operator or it is an operand. If it is an operand, push it in the stack. If it is an operator, pop the last two, apply the operator, push the result back. It's a very simple algorithm for evaluation. So these are the tasks for this lab, and that is the end of my explanation. Good luck. Thank you very much.